Well, is it going to die while it's recording?
It's recording.
Alright,
Annie.
predicting products. Now we're going to take everything that we've been doing and put it together all the way from Unit 3. So you need to be able to write formulas. You need to be able to balance. You need to be able to determine what type of reaction is taking place. Alright? And we are going to predict the products that are produced. Remember, reactants react to produce their products. So today we're going to be able to predict the products for single and double replacements and understand what the activity series is and what it tells us. So our essential question for today is, how do we predict products? The time to be awesome is now. We're going to bring it all together. So what is the difference between double and single replacement? Annie, do you remember? Abby had her hand up. Go for it, Abby.
Double.
So the single replacement, one has to start single and one has to end.
Yes, good job. One starts single, one ends single. Something's replaced, but something gets left single. Remember our little Jennifer Aniston example? And she was all sad and lonely at the end because somebody came in and stole her band, right? So, what is double replacement? Something gets replaced, but it's a double swap, right? So nothing's left lonely. So here you see Na now has a new partner, and H is with the OH. All right, this one confused a lot of people. When you see OH combined with H, that's essentially HOH, right? Why would we do that? Why would we write HOH? I'm talking about this part combining with this. So these two come together. All right, our cation and our anion. So what you get. Do we write it like that? No. How many H's are there? 2. Oh. So a lot of people are like, I can't figure out what this is because it's written like H2O. All right, that's why it's written that way. All right, so how do we predict products? Single replacement. Remember, here is our general equation. One element replaces another element. This is what you need that activity series for. It's in your notes there and on the back of your periodic table. All right, you will need the activity series. So as we see, remember, the metal switches with the metal, or the cation switches with the cation. Every now and then you will see nonmetals, so you'll see anions switch with anions. It just depends whatever's lonely. Whatever starts out lonely has got to switch out right. All right, remember, we always want to switch the two girls or switch the two boys. You never switch a girl with a boy. All right, that was our example last class. So let's look at single replacement. Elements that are higher on the activity series replace elements that are lower. Think of these as like ranking, who's best, all right? Or it is your football team. So you got the fantasy league, right? Everybody on the top is who you want to play, and everybody on the bottom is who you want to kick out. So if your lineup has a lot of people on the bottom, who are you going to replace them with? People on the top, all right? So elements lower would never replace somebody higher on the list. Would you take one of your bench players and put them in this game?
No.
No, all right? So the ones on the bottom are on the bench. Also another analogy here coming up for those of you who sports analogies don't. Are we good? Do we need another second to write? All right. So, for instance, who would get a date the easiest? Jabba the Hutt or Beyonce?
Java, definitely.
You will always tell me Jabba. All right. But for this instance, who in Hollywood would get a date quickest?
Depends on who they're going on date with.
If Java's going out with Silesius, then it's Java.
All right.
It's that
like
thing that's always beside him that has that weird laugh. Oh my God, that's great.
Beyonce, thank
I'm
you.
straight and I would date Beyonce.
Beyonce would get the date the easiest. So, we're going to pretend lithium is like Beyonce. At the top, alright? She can get a date with any other element. Anybody would date her, right? But Java down here at the bottom, HG. Everybody's H.
My
Nasty
mom was
thing.
pregnant, my dad, so my mom could look like her.
Oh, like Java? Oh, poor thing. So, Java's at the bottom of the list. Java easily gets replaced by any of these people. If this is the lineup, it's like, oh, all of these people are better than Java. If I have the option to take anything else on a date, I'm going to find it, right? Don't want to take Java. Do you want to take Java to the prom? No. All right, so Java is easily replaced but something at the top, you already got the best you can. All right, so it's not going to get replaced. So let's take a look at this reaction. Can it occur? 2K plus BaCl. So K is a metal, right? So it will replace the metal. So if we look, Ba is what we're in a relationship, right? Ba and Cl are together, so we're going to find Ba. This is who Cl is first with, all right? If it left Ba to go to K, is that an upgrade?
Yes.
Yes, so will this reaction occur?
Yeah.
Yes. All right, there's Ba, there's K. So you look at what's together, who's the couple? Remember we used our couples example the other day. Who's the couple? It is the one that's by itself an upgrade, right? Because we don't want to leave Ba all lonely and sad to downgrade, right? If you're in a relationship, would you break somebody's heart just to leave them from somebody worse? No, we want to
Some
make sure
people
it's an
do.
upgrade. Some people do, yes.
Very true, very true.
Usually with some regret. All right, so here's some steps. Find that single metal element. Check your activity series because we never want to downgrade. You never want something worse. Those of you who are sports people think you never want to put your bench players in the game if you don't have to. But if you can take somebody out and replace them with a trade that's even better, you want to do it, right? If you're not a sports person, think of Jabba and Beyonce. So if the reaction can occur, we're going to make that swap, and then what do you need to do in order to write your compound? We can't just swap it and leave it. We need the correct subscript, so you're going to swap, drop, and chop to make it a new compound. Right? If it can't occur, you just say no reaction. Nothing's going to happen here. It's not going to work. We don't want to downgrade. See a few people still writing. I'll give you another second. All right. So let's look at an example. KF and Li. I need to find a single metal element. That's why Li is written so much bigger. And we need to do what? Check and see if that's an upgrade. So K is currently with F. All right, so here's K. Li is up here. Would that be an upgrade for F to leave and go to Li?
Yeah.
Yes. So will this happen?
Yeah.
Yes. So step one, go ahead and make that swap. Look, Li is bigger because it's an upgrade. So now Fluorine said, "Oh, look at lithium over there." I'm going to say that's like Kelly and Lily. Fluorine's like, Fred goes, "Hey, look at Lily over there. I want to upgrade to Lily." All right? And so now Lily and Fred are together, and Kelly's all by herself.
Why do you make Kelly?
Because those are our two metals. Does that sound right? Do we want Kelly and Lily together? No. Following biblical principles here. We can't.
I'm sorry.
Yes, so that's why you check and see if this is a metal, it replaces the other metal.
No, that's not.
All right. So, in this case, the equation is already balanced, right? And we swapped, dropped, and chopped their charges. Lithium has what charge?
Oh,
+1. Fluorine is -1. All right, look, did I need any subscripts? No. So if I check to make sure it's balanced, I have one of everything, right? This was pretty easy to see. I've got one lithium, one fluorine, one fluorine, one potassium. We're balanced. That was easy, right? All right, so we made our swap, drop, and chop to make our new compound imbalance. Next one. Find a single metal element. So that's Rb. That's a metal, right? And we want to see, can Rb replace Li? All right, would fluorine be upgrading? Well, let's look. Here's lithium. Lithium's at the top. Fluorine is already with the best of the best. Do we want to downgrade for somebody on the bench? No. All right, so all you got to do is say no reaction. Or NR, same difference. You want to have shorthand.
So if it's not an upgrade, if it's not getting an upgrade, then no.
Right. You don't want to leave for something worse. Right? You never want to take a starter out and put in a bench player who hasn't ever scored a point, right? Look at the next example. Mg, F2, and K. So locate our single element. Would it be an upgrade from Mg? So look at your table. Fluorine is right now with magnesium. All right? It has the option to go up to potassium. So your arrow is always going to whatever's single. Is that an upgrade? So will that happen? Yes. So then go ahead and make that swap. Mg and K, switch. So now I have K with the F and an Mg. Look, K is plus 1, F is minus 1. Swap and drop. Right? And we swap, dropped, and chopped. I didn't need any subscripts because they were both what? 1. And then what do we need to do next? Yep, but what's the last step? Balance, yes. My steps are off at the bottom, but balance. So if we looked here, I have 1 magnesium, 2 fluorines, 1 fluorine. So what do I put here? A 2. And now I have 2 potassium, so what do I need here? 2. All right, awesome. So let's try and predict the products of the following reactions. So oxygen is currently with Ba. Would it be an upgrade to leave Ba to be with Rb? B is Ba at the very, very bottom? It's at the top, and then Rb is 2 more above it. Yep. So I'm going to write Rb, and Rb is now with O. Stop right there. What do we need to do to make sure we're writing the right formula? Swap, drop, and chop. So Rb is plus what? 1. O is minus 2. So that 2, remember, swap, drop, and chop, Rb 2, O 1. Do I need to write the 1? No. Oh, I didn't need to respond, but we'll just rewrite it. Rb. Alright, that's after we swap, drop, and chop. Alright, plus, and now what's all lonely by itself? Ba. So metals by themselves just exist like that. When we had our nonmetals like oxygen, chlorine, bromine, our super 7, diatomic, they need 2. But metals by themselves, just 1. Alright? So, I've swapped, dropped, and chopped. What's my last step? Balance. So, let's go ahead and make our tallies. Ba, and how many on the right side? 1 and 1. Oxygen on the left. Oxygen on the right. Rubidium on the left. Rubidium on the right. So where's my imbalance? Rubidium. I just need to put a 2 in the front. But guess what? I get lucky because does it affect anything else?
Nope.
No. So am I done?
Yes.
Yes. All right. Awesome. Let's look at the last one there. Hg and Na. So does Oscar want to leave Hilda for Nancy? Is that an upgrade?
What?
Nancy's way better. So let's leave, and now I have NaO. Oxygen got a good upgrade there, right?
Oliver.
And yes, Oliver got an upgrade there. And Hg is left all lonely and sad. Yes, we need to swap, drop, and chop. Great job. Na is plus 1. Oxygen's minus 2, so it's Na what? Na2O. Is it balanced? Put a 2 in front of Na. 1 and 1, 2 and, or 1 and 1, and now 2 and 2. Everything's balanced, and we're done. Alright? There's nothing more to it than swapping and writing your formula. There's no double checking that it happens, because if you're leaving somebody but you know they have a backup, do you care as much? Like, no, I'm not going to break their heart. They already have a plan B, right? They have somebody else. I have somebody else. We're all happy, right? So, in double replacement, they're just going to switch. Your metal switches with your metal. So here's your ballerina dancers. As long as they both have somebody to switch to, they don't care. So, same steps, except guess what's not missing? Or guess what's missing? And you don't need to do it.
Check your little chart.
Good job. You no longer have to check your activity series. As long as you're not leaving somebody lonely, you don't care. You're both happy. You're both moved on. And you can go on. All right? You just don't ever want to leave somebody lonely and sad if it's not an upgrade. Right? You don't want to break their heart unless it's worth it. Alright? So remember using your polyatomic ion chart to swap, drop, and chop in your periodic table for those charges. Alright, so let's take a look. Here's the first example. How do we predict those products? Remember, your metal switches with your metal. So if you see here, Ca is now with NO3 and Ag is now with Cl. So why here did I have one NO3 and over here I have two? Where did that two come from?
Oh, see,
Calcium. Calcium has what charge?
two.
Plus 2, so I just swapped and dropped and brought it over, right? Good job. So, let's do an example. Follow the general equation as step 1. So what do I switch? Na and K. Always switch your metal with a metal. If you didn't do Na and K, you could switch your non-metal or your anion with your anion. You just have to either switch the two fronts or the two back.
So let's have
Go ahead.
so if it's like A, B, C, D, ends up at N,
Yes.
so how do you end up with one that's H2O?
All right. So here's that same problem. Here's that same problem that you're talking about. All right. So here was your NaOH and KNO3. Here they switched, and you can see the D and the B switch, and now I have NaNO3 and KOH. All right. A is now with D. You switch the two backs, right? A is with D, and C is with B. Notice A and C stand in the same spot. All right? So, swap, drop, and chop, everything's plus and minus 1. So, I don't need these subscripts, right? And since everything's plus and minus 1, is this balanced? Yes. Notice that your polyatomic is present on both sides. Can we count it together as a group? Or balanced? Yes. All right, so it's already balanced. Everything, you only need one of everything, so it's already balanced. Let's go through the second example here. Remember, we're switching a metal with a metal. All right, so general equation, here it is. I switched my two anions. Literally just switch them. Like if I could pick these up, if I could move them with a little mouse, right? I would just pick up OH and move it to be with Ca, and SO4 would come over here to Mg. They switch like some ballerina dancers on the floor, right? So a little picture that was up there. And then we need to write our charges and make sure we swap and drop appropriately. Well, when we do, how many OHs do I need? 2. And since Mg and SO4 are both plus and minus 2, do I need any subscripts? No. So, that's all you're doing. Is it balanced? Yes.